Geometry, Chapter 10, Lesson 3. Now that we've looked at the apothem and the radii and these triangles that are formed, let's take a look at some of the characteristics now of this triangle and some of the calculations that we can make as far as the measure of the angles. Now, as we've talked about already, if we draw two radii and they're consecutive, they do create these isosceles triangles. Now, how many triangles are formed if I draw all the radii? And if you did a little investigation here, you would come to know that however many sides there are, that's how many equal triangles are formed when you draw all the radii. This is a 6-sided figure, so I'm going to get 6 triangles. If I had an 8-sided figure, I would get 8 triangles. If I had a 10-sided figure, I would get 10 triangles. Now this is very important because the number of triangles that are formed is the first step in calculating some values that I'm going to need for this formula that we're going to look at. So the number of sides and the number of equilateral triangles that are formed are the same. And as I've already talked about before, if you found the area of one of these equilateral triangles and then added all of those together, that would equal the area of the polygon. Okay? And again, that would be one way to do it. The formula that we're going to look at is going to allow us to do it a little bit differently, but just understand what could happen here. Now, how do we figure out the measure of one of these vertex angles? In other words, we have these equilateral triangles. No, we don't. We have these isosceles triangles. And how could we measure or calculate? I think I just showed you the answer. How could we calculate the measure of one vertex angle? Because they're all the same, I only need to measure one, and then I could figure out all of them. Well, look what happens if I draw all of these vertex angles. I draw that one, I draw that one, I draw that one, I draw that one, and I draw that one. If I put all of those vertex angles together, what do I create? A circle. And how many angles, or how many degrees, excuse me, are in a circle? Well, there's 360 degrees. Well, if these are all isosceles triangles, and they're all congruent, that means all of these angles up here are going to be the same measure. So how could I find the measure of just one? Well, I know what they all add up to, 360. I know how many triangles there are, equals the number of sides, in this case 6. So to find the measure of one, I simply take 360 and I divide it by how many triangles there are, or how many sides there are. So 360 divided by 60 means that one of these angles is 60 degrees. So each of these would be 60. 60, 60, 60, 60, 60, and 60. And if you added all those together, you would get a total of 360. So the first step in determining what we're going to need for our formula, and I know I haven't told you what it is yet, but the first step that you're going to need to do in using that formula is to figure out the measure of that angle. So 360 divided by how many angles there are, how many triangles there are, which is equal to the number of sides, is going to give you the measure of those angles. So let's do an example or two. So what would be the measure of this angle right here? I draw two consecutive vertices, two consecutive radii. It forms this triangle. The question is, what's the measure of this angle right here? Well, I know it's going to create 3 triangles, and so I take 360, I divide it by how many sides there are, 3, and so the measure of that angle is 120 degrees. So that vertex angle is 120 degrees. It's that simple. What would be the measure of this angle? Well, 360 divided by how many sides are there? 1, 2, 3, 4, 5. So that would equal 72, right? Okay, so determining the measure of that vertex angle is not too difficult. Now, one more thing we need to talk about again, and this is all setting up for us to be able to use the formula that we'll introduce in the next video. We already know that if we draw 2 radii, we can find the measure of the vertex angle by taking 360 and dividing it by how many sides there are. That's because when you draw radii, they create these equilateral, or these isosceles and congruent triangles. Now, what happens when you take that triangle that you get by drawing 2 radii and you draw the apothem? Well, if you remember from earlier this year that if you bisect this angle of an isosceles triangle, or if you draw this side perpendicular to this other side, it does two things. It cuts this angle in half, which we can figure out by doing 360 divided by the number of sides. And it also cuts this side in half, so it creates two equivalent segments. Alright, so when you draw the apothem, it does two things. It cuts that angle that you figured out by doing 360 divided by the number of sides. It cuts that angle in half. And then it also cuts the side of the polygon in half. So by doing that, that's going to give us then a right triangle. We're also going to be able to determine what one of the angles in that triangle is. So we can then again go back to something we already know. We can do Pythagorean theorem if we happen to know two of these sides. If not, and one of these angles happens to end up being a 30-60-90, which this one does, or a 45-45-90, we can use those special triangles to figure out the lengths of what I might need for my formula. Or if it's not a 30, a 60, or a 45, we can use, possibly, trigonometry, sine, cosine, or tangent, to figure out a length that I'm going to need for my formula. Okay? So the idea and what we've done in this video is we've laid the foundation for using the formula that we'll look at in the next video. And the things that you're going to have to know in order to do that is, when you draw two radii, you can figure out the measure of this angle by doing 360 divided by the number of sides. If you then draw the apothem, it cuts that angle in half, and it also cuts this side in half, which again is going to allow us to use the formula that we're going to use in the next video. So let's practice finding the measure of some of these angles. So determine the angles of the small triangles, okay? So what would be the measure of this angle here, and this angle here? So I'm going to need to determine the measure of all of those angles, okay? Now, if we take a look first at the big triangle, where we draw two radii, if I take 360 and I divide it by how many sides I have, and in this one I have 8 sides, that's going to give me the measure of this angle of the two radii. So that's the big angle. Okay, so 360 divided by 8. So that's going to be 45. Okay, now when I draw the apothem, it cuts the angle in half and actually gives me the measure of this angle right here, because this is half of that one. So 45 divided by 2 is 22.5. So this angle here is 22.5, right? I know that this is drawn perpendicular, so I know that that one's a 90. So I know that this one's a 90. So I can figure out this angle here by doing 90 plus 22.5 and subtracting that from 180, and that will give me the measure of this angle here. So 90 and 22.5 is 112.5. If I subtract that from 180, that's going to give me the measure of angle 2. So that's going to give me a measure of 67.5. So I can figure out the measure of the angles by doing 360 divided by 8. Now what you have to remember, that gives you the big one, okay, or the angle, vertex angle of the isosceles triangle. You then draw the apothem. That's what cuts that in half. That gives you the angle in this side of the triangle. This one's always going to be 90 because the apothem is perpendicular to the side. And then using what you know about the triangles, all the angles adding up to 180, you can get the measure of this angle here. One more example to give you a picture of what you're going to need to do. So if I wanted to find a measure of all of the angles in the small triangle, that's the small right triangle, we can figure out the measure of the larger isosceles vertex angle by taking 360 and dividing by how many sides we have. So doing this, that gives me a measure of 72. The measure of the small angle here in the right triangle then is simply this vertex angle divided by 2. So I'm going to take that number that I just got and divide it by 2, so that's 36. So the measure of this angle is 36. This angle is always going to be 90 because I'm drawing the apothem perpendicular to the side. So to determine the measure of this angle down here, I'm just going to use the fact that I know that all angles in a triangle add up to 180. So 90 plus 36 plus the missing angle needs to equal 180. Solving this equation, I've got 126 plus this angle is 180, and subtracting 126 from both sides, I get 54. So the measure of this angle here would be 54. So to determine all the angles in that triangle, you simply follow that three-step method. Figure out the vertex angle by doing 360 divided by number of sides. The apothem cuts that angle in half. That gives me the angle then of the right triangle. The other triangle, or the other angle of the triangle, then is simply found by taking the two angles that I know plus the one I don't know, adding them up or summing them to 180, and then determining the missing measure. All of that's laying the foundation then for the formula that we're going to use in the next lesson or in the next video. We'll give you the formula and show you how to use that formula to find the area of a regular polygon.